Good morning, students. Welcome you all for Next Generation Learning. Today, we are going to see the subject Physics and Class 10. Chapter number 12 Electricity. Topics 12.2 Electric Potential and Potential Difference. Under this topic, we are going to see the definition of electric potential, electric potential difference, 1 volt, and voltmeter. The last class I given some question as a homework. Now I'm going to discuss the answer for those questions. The first question, define electric current. You know that the movement of electric charges constitute electric current. Electric current is expressed by the amount of charge flowing through a particular area in unit time. So the amount of charge flowing through a wire in particular area in unit time, that is called electric current. Otherwise, we can say that the rate of flow of electric charge constitute electric current. You have to write this sentence. The rate of flow of electric charge. The rate represent time. And the equation I equal to Q by T, where Q is the charge, T is the time. The next question, write down the relationship between the electric current I passing in a conductor, charge Q flowing in the conductor, and time T. So what is the relationship between these three terms, electric current I and charge Q and time T? You know I equal to Q by T. So this is the relationship between I, Q and T. The next question, write SI unit of electric current. The SI unit of electric current is one is ampere and another one is coulomb per second. So there are the two SI unit of electric current. One is coulomb per second and another one is ampere. This is the SI unit of electric current. The next, define 1 ampere electric current or SI unit of electric current. The SI unit of electric current is ampere. And it is same as define 1 ampere of electric current. The answer is 1 ampere is constituted by the flow of 1 coulomb of charge per 1 second. So 1 ampere is 1 coulomb of charge per 1 second. That is called 1 ampere. 1 ampere is constituted by the flow of 1 coulomb of charge per 1 second, that is called 1 ampere. How is the direction of electric current related to the direction of flow of electrons in a wire? In an electric circuit, the direction of electric current is taken as opposite to the direction of the flow of electrons, which are negative charge. See here, this is a battery, positive terminal and negative terminal, positive terminal and negative terminal. So the direction of electric current is always positive terminal to negative terminal. But the negative sign represent electrons. The electrons are moved from this direction. The current is this direction. So in an electric circuit, the direction of electric current is opposite to the direction of the flow of electrons. So the direction of electric current is opposite to the flow of electrons. Are you clear? How is the direction of electric current related to the direction of flow of electrons in a wire? The electric current direction is always opposite to the flow of electrons. Name the instrument used to measure electric current in a circuit. So, which instrument is used to measure electric current in a circuit? An instrument called ammeter measures electric current in a circuit. So the ammeter is the instrument. It is used to measure the current in an electric circuit. How is ammeter connected in the circuit to measure electric current? It is always connected in series in a circuit through which the current is to be measured. So if you take in an electric circuit, this is an electric circuit, you have to connect the ammeter in the series to the connection. So it is always connected in a series in a circuit through which current is to be measured. I hope you understood these answers. If you write wrong answer, please correct it. Now we are going to see today's topic 12.1 electric potential and potential difference. What makes the electric charge to flow? Look at this diagram. This is a conductor. This is a conductor. In this conductor, the electrons are moved from one atom to another atom. So what makes the electric charge to flow? Here I connected the battery. So the battery makes the electrons flow from one atom to another atom. So before going to see what is maybe potential and potential difference, we have to see the analogy of flow of water. So what is meant by analogy of flow of water? Look at these two diagrams. In a first diagram, the tube is connected to the tap at A and at A point and B point. The water level is same. So the pressure difference between the both the point A and B is same. So there is no flow of water. If I need flow of water at end A, what shall I do? So I just write the end B here. When I write the end B, there is a difference. The water level at A and B is varying. So due to that, the water is started to flow at end A. Are you clear? In the first diagram, at A and at B, the water level is same. So the pressure is same at point A at point B. So there is no flow of water at tap. If I need to flow of water, I have to raise the end of B so that the pressure level is varying at A and B. So when the pressure level is changed, the water is started to flow. Water in perfect what water in perfectly horizontal tube does not flow. So when the water in perfectly horizontal tube, it does not flow. It was represented in the first diagram. If one end of the tube is connected to a tank of water, here look, at one end of the tube is connected to a tank of water kept at higher level, such that there is a pressure difference between the two end of the tube. Water flows out of the other end of the tube. So when I connected the tank at end B, the pressure level is varying so that the water is continuously flow out at the tap. So when it reached same level, there is no flow of water. But I need continuous flow of water in the tap. What shall I do? Are you clear in this diagram? When I connected the tank at one end of the B, the pressure difference is varying so that the water is continuously flow in the tap. But after a certain time, the water level is decreased. It reached the same pressure at end A, B and tank. So there is no flow of water. For continuous flow of water, some external agents it required. So if I need a continuous flow of water in the tap means I need some external agent. So what is that external agent? Here motor is attached to ensure continuous flow of water. So in the tap I connected the motor. So this motor collect the water from the tap and this water is again passing through the tank and this water is again go into B to A. So here I get continuous flow of water. So for continuous flow of water, some external agents are required. Here motor is attached to ensure continuous flow of water. The same as if you take a conductor, the conductor consisting of electrons. Because every conductor consisting of atoms, each atom consisting of electrons. When there is no pressure difference at A and B, there is no flow of electric charges. The same as the water. So charges do not flow in copper wire by themselves. So when the charges can flow in the conductor, I have to connect the external agent. So when I connect the external agent, the electrons are continuously flow in the circuit. When the electrons are continuously flow in the circuit, the electric current is produced. Otherwise, there is no electric current. So when the conductor is simply like that, there is no flow of electric charges. So there is no electric current is produced. The electrons move only if there is a difference of electric pressure called potential difference along the conductor. So when I connected this conductor to a battery, so there is a potential difference at A and B is changed. So that of that electric pressure, the electrons are started to move from one atom to another atom. So it constitutes electric current in the circuit. So this difference of potential may be produced by battery consisting of one or more electric cells. So here I took the chemical cell, the battery or chemical cell. If a battery means it consisting of one or more cells. So here I used the cell as an external agent to produce the continuous flow of electrons. So the chemical action within a cell generates the potential difference across the terminals of the cell even when no current is drawn from it. When I connected the chemical cell to the conductor, this chemical cell generates the potential difference across the positive terminal and negative terminal of the cell. This is a positive terminal and negative terminal. But it does not uh, drawn any current from the outside. Within the cell, it creates a potential difference. Due to the chemical reaction, it creates some potential difference between the point A and point B. That means the terminal A plus the terminal positive and terminal negative. When the cell is connected to a conducting electric circuit, the potential difference set the charges in motion in the conductor and produce an electric current. So when this electric cell is connected to a conductor, it creates a potential difference between A and B so that the charges are continuously move in the electric circuit so that electric current is produced. In order to maintain the current in a given electric circuit, the cell has to expend its chemical energy stored in it. So if I need continuous flow of electrons in the circuit means I have to maintain the chemical energy stored in the electric cell. Once the chemical energy is evacuated, there is no potential difference between A and B. So there is no flow of electric charges. When there is no flow of electric charges, there is no current produced. So I have to maintain the chemical energy stored in the electric cell. This is a electric cell. It is represented by one long line and another one short line. The long line represent positive terminal and short line represent negative terminal. In a battery means it consists of one or more cells. This is battery. Here it consisting of three cells. When one or more cells are connected together, that is called battery. Now we are going to see what is meant by potential difference. Here I connected a battery. So this battery gives a potential difference at A and B end so that the electrons are flow from A to B. The electric potential difference between 2 points, the 2 point is nothing but at A and B. See here, this is a conductor. For this conductor, I drawn in this way. So this is end A means this is end B. So here I write end A and end B. This end A and B is connected to a cell. That means battery. So the potential difference between 2 points in an electric circuit carrying some current as the work done to move a unit charge from one point to another point. So when I connected this battery to the circuit, it is used to give a potential difference from work done to move a unit charge from one point to another point. So when the electrons are moved from the end A to end B, then only the electric current will be produced. So who give this energy to electron? The external battery gives the energy to move a unit charge from one point to another point. So potential difference between 2 points equal to work done W by charge Q. V equal to W by Q. Here the V represent potential difference between point to point. That means A point and P point. The potential difference between 2 points is the work done to move one charge from point A to B. So I can write V equal to W by Q. Here W equal to work done, Q equal to charge. The SI unit of work done is joule and SI unit of electric charge is coulomb. So we know that V equal to joule per coulomb. So the SI unit of potential difference is joule per coulomb or volt, the same as ampere or coulomb per second. In electric current, we say that no, the SI unit of electric current is ampere or coulomb per second. The same as the SI unit of potential difference is joule per coulomb or volt. So who given this unit? The SI unit of electric potential difference is volt. It is represented by capital letter V, not small letter v, capital letter V, named after Alessandro Volta in Italian physicist. So who found the SI unit of electric potential? The Alessandro Volta found the SI unit of potential difference. So the potential difference equation equal to V equal to W by Q. Here W equal to work done. The unit of work done is a joule. Q is electric charge. The unit is coulomb. So the SI unit of potential difference is joule per coulomb. Here it was missed. That means joule per coulomb or volt. So what is meant by 1 volt? 1 volt is the potential difference between 1 volt is the potential difference between 2 points in current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to another. That means we know that V equal to W by Q. So what is meant by 1 volt? 1 volt equal to 1 joule of 1 joule of work done by 1 coulomb of charge, that is 1 volt. When 1 joule of work is done, to move 1 coulomb of charge from one point to another point, then the potential is called 1 volt. The next one, voltmeter. What is meant by voltmeter? Look at this image. This is a voltmeter. It has two terminals. One is negative and another one is a positive. The red always positive, the black always negative. And it has some ranges 0 to 6. So we can measure the voltage from 0 to 6. So this is an instrument used to measure the potential difference between 2 points. The potential difference is measured by means of instrument called the voltmeter. So using voltmeter, we can measure the potential difference between 2 points. The voltmeter is always connected in parallel across the point between which the potential difference is to be measured. In ammeter, in electric current, we know that the ammeter is used to measure the electric current. The ammeter is always connected in a series. But if you measure the potential difference between 2 points, you have to connect the voltmeter across the point. Here I have to measure the potential difference at this end to this end. So here I connected the voltmeter across the across this electric bulb. If I need to measure the potential difference this between this end to this means here I have to connect. So the voltmeter is always connected across the terminals, but ammeter is always connected in the series. So this is the difference between the voltmeter connection and ammeter connection. I hope you understood what is meant by potential difference and what is meant by 1 volt and voltmeter and where we have to connect voltmeter and etc. You have to answer for the following questions. The first one, define electric potential. The second one, state the relationship between work W, charge Q and electric potential V. The third question, what is the SI unit of electric potential? The fourth question, define 1 volt of electric potential. The fifth question, name the instrument used to measure the electric potential difference. The sixth question, how is voltmeter connected in the circuit to measure potential difference? Thank you for watching. Dear students, after watching this video, you have to take your notes. Within 11 o'clock, you must watch this video and take notes. When I conducted the meeting, the teachment meeting, you have to answer for my questions. Don't say that I didn't watch the video. And also, you have to show your notebook whether you took notes or not I have to check. Everyone want to attend the meeting. And also you have to complete your subject enrichment activity, portfolio and multiple assessment. And you have to take your note textbook. You have to mark the point what I taught in the video.